are. So, good morning, everyone. I'm doing good. How are you guys? All right. So you should be able to see my screen by now. As usual, I'm checking the live chat channel. So if you have any questions, any comments, that's the place that I'm constantly checking. I'm glad to see that people are doing well. I see your messages in the chat. So we are on week 12. So if you haven't done so, go on Codio. We're going to be working on Intro to SQL Part 1. So this is the time to be doing that. So a quick recap of this whole course so far. At first, our very first lecture, if you guys remember, was our data literacy lecture. So we were talking about the skills that we need to become data analysts, the skills that we need to be data fluent. So we were talking about how it is important to know how to read data. So for example, if you're presented with a bar chart, you know how to interpret the bar chart correctly. If you're presented with a statistic, you know how to interpret that statistic correctly. So we've been doing that here and there throughout the program. We also have talked about translating data, so how to communicate your data so your analysis and your hard work doesn't stay just in an Excel sheet or in a dashboard, but the message gets through your audience. Your audience could be your manager, your colleagues, maybe a client. And we also talked about thinking about data, so how to formulate good questions that we can answer using data. And then we also talked about writing data. So that's a lot of the things that we've been doing in this program, learning how to use the different tools that you need as a data analyst to be able to write this data. So some of the tools that are the most required by the industry are the ones that we're covering here. We started covering Excel. That was a long while ago. The Excel days are behind us. Maybe not for your professional life, but for us, they're behind us. Then we worked with dashboarding. We actually learned two tools, Looker Studio and Tableau. Then today we're going to start with SQL. We're going to have several classes of SQL. I must say that the SQL classes are a little bit faster than usual, so I want everyone to have patience. You have impatience with yourself and also with your instructors. If we're going a little bit fast, that's completely normal if at first it feels like too much because it's completely different from Excel and from dashboarding. And then towards the end of the program, we're also going to cover Python, but that's towards the end of the program. Oops, sorry, guy. Sorry, guys. Let me check this. I actually have to pick up this call. Just give me 1 second. I'll be right back. Yeah, this is Marcus. Oh, hi, Agent Briggs.
Viviana, you're on mute if this is part of the thing. I thought you had an actual phone call.
So Agent Briggs, how can I help you? You were telling me that someone got murdered? But that's fine. No worries. It's a cold case, so I'm gonna help you solve this cold case. Welcome to Murder in Sequel City. Can you solve the mystery? It is a misty September morning in Sequel City, California. You're relaxing at your office, reading the newspaper and drinking coffee. When the telephone rings, is the familiar voice of one of your high profile contacts from Washington. He wants you, the most renowned private investigator in town, to help the FBI solve a top secret cold case. Will you be up to the challenge? He tells you that there was a murder back in 2018. The first investigation didn't produce any definitive results. The bad news is that the original crime scene data was lost because it was stored in an Excel workbook. And the Excel files, of course, they got corrupted. As if this was not enough, the detective who led the inquiry back then forgot many of the key details of the case. How convenient! The only thing that she vaguely recalls is that the crime occurred sometime on February 18, 2018. The good news is that the data was copied to a relational database before the Excel files were corrupted. All the clues that you will need to solve a case are buried in there. You're always down for a good mystery. So, of course, you say yes. You say yes. Let me see in the chat. Will you be up to the challenge to solve this murder mystery? Fantastic. I know I have the best team in town to solve this murder mystery. I see all those yeses coming into the chat. So today we have a very special case because not only are we going to learn SQL, that's not important. We are going to be solving a murder mystery. All right, so let's get started. As I was mentioning at the beginning of the lecture, we are going to be working with SQL. So go on week 12. That's going to be SQL City, Murder in SQL City Part 1. So that's what we're going to be working with today. And that's the goal for today, to get started with SQL. So um, many people, all of us here already know how to work with Excel, which is it's pretty intuitive. So I think that's the biggest challenge from going to Excel to SQL is that Excel is very intuitive. You have a file, you double click on the file, and it opens on your Excel on your computer. SQL is not so intuitive, but there's a reason why we would want to work with SQL. So Excel has a lot of limitations. Excel, for starters, it has a maximum size of data that you can have, which is a challenge in this modern world where so much data is being produced every single minute. So in theory, you can load a file this big in Excel. So about 1 million rows and 16,000 columns, which sounds like a lot, but it's not a lot. Imagine if you have 1 million customers, you're a business, you have 1 million customers, and each customer has at least 100 transactions. So just right there, you have 10 million rows. So this is not a lot of space. And in practice, the limit is much smaller because many personal computers would just crash at that amount of data if you try to open it on Excel. And then even if you're able to open such a big file, if you try to do something like a VLOOKUP, your Excel is just going to crash. So Excel is good if you don't have a lot of data, but if you have massive amounts of data, maybe Excel is not the best option. So then, oops, let me skip here. So if it's not Excel, what do we do? So let me give you another example of how Excel would not be a good tool to use depending on the situation. So imagine you're a bank and you're using Excel and someone has $500 in their account and they go to the ATM and they take out $100. So what would you do? Open the Excel file, update the balance, and then save the Excel file? That could work, but imagine if that person has shares their account with their spouse, and their spouse happens to go to another ATM in another location and also take out $100 at the same time. So two people on the same account, they're taking out $100 at the same time. If you try to do this in Excel, imagine you have a data analyst in the first ATM location and then another one in the second ATM location. That could create conflict because then in Excel, maybe you do the two things at the same time or something happens and then you're not tracking the changes correctly. So SQL takes care of all those situations. It's a more robust and efficient way of dealing with big data sets and data sets that are more sensitive, like the bank example. So if it's a bigger analysis, a bigger situation, you're going to be working with relational databases. So what is a relational database? A relational database, well, there's not an explicit definition for databases, but basically it's a place where you can have different structure data that you can later on use. And relational databases, So databases is just a place where you have a lot of data. And then relational databases are the most popular ones. And relational databases in a way are similar to SQL because they're also in tables. You can have databases where you don't have tables. You have like documents or text or log files, but that's not what we're going to be doing for now. We're still going to be working with tables, but tables that would you wouldn't be able to work on just by using Excel. So that's where we are today. And they're called relational because they're based on relations. So the tables have relationships between each other. So we'll see in a brief second what that is. So here's a sneak peek of our one of our tables in our database. So this table is the table that contains information about people in general. We don't know what kind of people, but we have people in here. So you have ID 1, 2, 3, 4, and 5. We have the name of the person, the driver ID, the address, the social security number, and the income of each person. So we just have some data on these people. So now that we're migrating onto the world of SQL, some things are going to have a different name. Just the same way when we were working with dashboarding, we were talking about metrics and dimensions, and you have this correct terminology. Now let's look at the terminology here in the world of SQL. So if you have a table, most tables will have something that is called a primary key or yeah, primary key could be one primary key or several primary keys. And the primary key is a column that allows a column or columns, it could be more than one, that allow you to uniquely identify each one of the rows. So in this case, it would be ID. It could be social security number because not more than two people will have the same social security number, but that's usually defined by whoever creates the database. What column is going to be that primary key? But in this specific case, it's just the ID. It uniquely identifies each one of the rows. This is something important when you're talking about databases and if you are creating a database, you have to think about what is going to be your primary key. For example, a primary key that would be really bad would be name. Because sure, a name uniquely identifies you, but if you're working with, for example, a data set that has everyone in the United States, you probably have more than one John Smith because it's a really popular name. So how do you distinguish between all the John Smiths? Through their ID. So you should you should know you should know that when you're working with a primary key, it uniquely identifies each one of the rows. Same thing, in this case we have people, but if you had products, an ID for each one of the products. So that's what a primary key is. And everything else, all the other columns are attributes. So this is terminology. It's not just so you know what terminology to use when you're presenting at an interview. But in simple words, primary keys and attributes are just columns, the column names that we have in our database. The primary key is just the one that allows us to uniquely identify each one of the rows that we have. Um, so now let's go back to our crime database because that's what we're going to be doing here today. We're going to solve this crime. So if you guys watch criminal shows like Criminal Minds or CSI or Blacklist or any of these shows, you probably see that whenever they're trying to solve a crime, they always have like a board. And in their board, they have like pictures of the suspects, pictures of the victims, newspapers, clippings, and different data. And this is not to make this set look cooler to the audience. This is what actually happens in real life because investigators need to look at everything that is happening to be able to connect the different clues and solve the case, solve the mystery. So, same thing with databases. We can look at what we have in our database to see how different tables connect with each other. And we call that entity relationship diagrams, or ERDs for short. So, what is the entity relationship diagram of our database? So, this is actually the ERD of the database that we're going to be working with for this case. So we have in the ERD, you can see how many tables do you have in your database. So in this database, we have one, two, three, four, five, six, seven. So we have seven tables. If we were in Excel, it would be like a workbook that had seven sheets, but we're no longer in Excel. So we have a database that has seven tables. Each table has a name. So typically here we see it at the top, and notice that we have like a table symbol here next to the name. So the name of this table is the individual table. This one is Facebook event. This one is gym record, gym affiliated, drivers, crime scene, and interrogation. And then in here, you can also see which one is the primary key. This is going to vary from ERD to ERD, but in this specific ERD, we know that the primary key is the primary key by two things. The font of the column name is bolded, is at the top, and it has this key symbol right next to it. So for individual, the primary key is ID. For the table gym affiliated is ID as well. For drivers is ID as well. For integration is individual ID. But notice, for example, Facebook event, it has two columns that work as primary keys, because notice the small keys in here. So individual ID, event ID, affiliated ID, check-in date for gym record. And crime scene actually has four primary keys. So you need those four columns to be able to uniquely identify each one of the rows. This is typically something that is designed for you. This is the job of the data engineer to create this database for you. So you don't have to worry too much about this, you only need to worry about, okay, I can look at an ERD and I know what it means. And the other things below here are just the column names. So for example, for individual, we have name, driver ID, address, social security number, income, and next to it, we have the type of the column. So this is a text column for name, for driver ID is a number column, and so on. And last but not least, we also have the concept of foreign keys. So foreign keys are the attributes, so the columns on the other table that allows you to connect two tables. So for example, individual the individual table, the primary key is ID. And the interrogation table, the primary key is individual ID. But then for the individual table, the individual ID is the foreign key that links these two tables. So primary key is the key, the one that allows you, the column that allows you to uniquely identify each one of your rows. And then the foreign key is that but of the other table and the one that links these two tables together. So there you go. So that was a little bit of on terminology. Now we are gonna get on to the action. So what do we do as detectives? As detectives, we have to ask a lot of questions. So how do we ask questions to a database? If you want to know the name of someone, the driver license of someone, we want to know the social security number of the suspect. How do we ask the database these questions? So that action is called querying. So you would say, I'm going to query the database, which is the same as saying, I'm going to ask questions to the database. And that's where SQL comes from. So SQL is short for structure query language. So it's a programming language. And just like natural languages like English, Spanish, Mandarin, you have to practice them to get good at them. So you're going to have to practice a lot of SQL to get very good at SQL. The good news for all of you is that SQL uses English words, English keywords. So for you guys, it's easier. Whenever I have to teach this class to my students in Colombia, it's a little bit harder because the keywords are in English and people in Colombia speak Spanish. So they're like, what does that mean? But you guys have an advantage because the SQL query, a lot of times, even if you don't know what it's doing, you can kind of read the query itself and kind of figure out what it's doing. So that's an advantage of these programming languages. So that's SQL. Also, some people call it SQL. In my master's degree, everyone called it SQL. And I don't know if this is maybe like a state thing. In California, I did my master's degree in California, and everyone called it SQL. And then I moved to Florida, and I was searching for a job, and I was talking to recruiters, and they were asking me, "Do you know SQL?" And I was like, "I've never heard of that. I don't know SQL." And then after a while, it clicked, oh, wait, that's actually the same thing. So don't be me. If you're talking to a recruiter, be confident and say, yes, I know SQL or SQL, whichever one of the two. So let's get ready to make the database speak. So SQL works a little bit similar to Excel in the sense that you know how you have Excel, but you can actually open Excel files in Google Sheets, Numbers, and all these other apps. So same thing for SQL. So SQL is the language of the query that we're going to be writing, that's SQL, but you can actually run SQL in many, many different places. So the easiest place where you can run it is called SQLite. We actually want everyone to be able to access this regardless of your computing power. So in fact, you can go on Codio and just run it directly from Codio. So that's what I'm going to be doing here and showing you guys. But if at any moment maybe you want to have it at home, like download it onto your own computer, you can download it from here completely for free. You don't have, again, I want to be super clear, you don't have to do this now. You don't have to download this. You can just follow along in Codio. This is just if you want to work for it from your own computer. So let me show you how it looks from a computer. At work, you're probably going to be running it from the computer. And I'm running it from this DB browser. There are other tools. And this is how it would look like. So let me open it for a second. So this is how it would look like. But in here, we are going to be working with Codio just so everyone has access to the same tool. But just so you know that those options exist. So here is where I want everyone to be on the same page as me, and then we can start ramping it up. So I want everyone to be in the Codio guide for week 12, which is the one for SQL part one. And we are gonna open the page 7 or the one that says database, the database. So I want you all to be here. And if you see this black screen, that's completely normal. Just click on Start SQLite Browser. So you should see something like this. So click on, make sure that you're on page 7, the database, and click here on Start SQLite Browser. All right, I see some thumbs up. I'm gonna wait here for a few seconds so everyone can be here. So I see those thumbs up coming up. I see a few people that it's still loading for them. If it's forever loading, maybe try refreshing the whole page in case if it's an issue with Codio. In the meantime, while I wait, I saw a question of someone asking the difference between SQLite and MySQL. So they're different, like database programs, but the language that you use inside of them is SQL. So everything that you learn in SQLite, it's gonna apply in MySQL as well. SQLite is just lighter for your computer. It's more portat portable. For the people working with the desktop version, I can send you the file in the chat. That's only for the people working in the desktop version. For those of you that are that Codio is saying still executing, I would love it if you could send me a screenshot so I we can talk to the Codio people and let them know that they're being a little bit slow. Um, but yeah, I see that some people it's still working for them. So my recommendation, you don't have to do this, but my recommendation is that I would like click here between the two screens and make this one smaller so you have more space to see all the SQL thing. This is completely optional unless you want to follow the guide. But I'm gonna do this in my case just so I can visualize better what's happening. All right. Seems like most people are there. Um, the other thing that I would do is click here. This what basically what Cody is doing is allowing us to use their computing resources. So this is like a computer within a computer, if that makes sense. So I'm gonna click here on this button. So I open the window, and now we're fully covering the whole screen. For those of you that you're seeing a black screen, then maybe I would try downloading from the link. Let me share the link again in the chat. I mean, the first thing I would try is refresh Codio, see if that does the trick. Maybe click on this button here as well that refreshes the preview. But if not, try downloading it here onto your own computer. That's an alternative, but yeah. So this button makes it larger. This one right here makes it cover the whole screen. Yes, you can have the file. Let me send the file in the chat again for those people working directly from the desktop. All right. So let me give you a walkthrough of what we have here. So this is SQLite. This is a DB browser for SQLite. That's the name of the program that we're working with. Um, and basically what we care about is going to be here. So here you have new database. We're not going to be creating a new database, so not really using this button. We have open database. So that button we're going to use in a few seconds to open the database file. Here we have the database structure. So once we open that file, we're going to be able to see the database structure in here. Here we have another tab that is browse data. That's going to allow us to visualize the data. We don't really need this edit pragmas for now, so we just leave it alone. And then we have execute SQL where we're gonna write our queries. So that's what we're gonna be doing first. So far, I haven't done anything. I'm just showing you around. So that's what we're gonna be doing next. We're gonna be opening that DV file. So I'm gonna go here on Open Database. And when you open it, you should see this little window, and you should be able to see this crime database.db file. And then, of course, click open once you have it. So once you open the file, so far I have only done one thing, which is to open the database. So click on open database here, and then select the crime database.db file. That's everything that we have in there. The file should be in there if you're working from Codio. If you're not working from Codio, let me send you this file in the chat. And okay, so let me walk you through this again. So you click on open database. Once you open the database, so here I open the database. In the database structure, we see the same thing that we were seeing before in the ERD. So we have 7 tables. These are each one of our tables. And then if you click here in the caret here, you would see the columns of the tables. So for example, for crime scene, we have these 5 columns. And in fact, you can see the ones that are primary keys because they have a key symbol in there. So for example, individual, we have the ones in here. And it tells you what type of data do you have in each one of those columns. I am sharing my screen. If maybe gotten pinned on in Zoom, I can't do anything on my end, but in Zoom, maybe at the top you see the speaker sharing screen button. Um, all right, cool. So that was the database structure. If you click on browse data, you can actually see the data for each one of the tables. This works in SQLite because we're working with a small database. Of course, if you were working on a much bigger database, it wouldn't be so easy because then your computer would crash if you try to visualize all your data. But for now, you can see it here. So we can do that transition from Excel to SQL. So in Browse Data, here you have your different tables, and you can just look around at all your different tables. So that's just for you to see the different tables and the different data that you have. Um, and then the most important window that we're going to be working with is this execute SQL window. So here is where we're going to be writing our queries. So to be able to work with our data, in Excel, you had to select your data. Maybe you had to click some buttons, create a pivot table, or write a formula. In SQL, everything that we're going to be doing with our data is going to be in this window by writing instructions. So we have to write instructions. We're going to be writing those queries. That's what we're going to be doing next. But before I explain what is going to happen in this window, I wanted to get a sense of how are we doing in the room. Are we here with our database loaded? Are we having issues with Codio or some other type of issue? So let me see. So I'll do a quick recap. It seems like it's mostly thumbs up, but I'll do a quick recap. Also, during the break, you'll have a time to load your SQL if it's not working. But for now, let me do a quick recap. So we are on week 12, page 7. Uh, you should click on Start SQLite Browser if you haven't done so. So a window here appears, window like 90s looking window should appear here. And then we clicked on Open Database, Crime Database, and that's where we are. We haven't done anything so far? Right. So now let's focus on this execute SQL window. So there's a few things with this execute SQL window. So here is where we're going to be doing most of our work. This is where we are going to be writing the queries to get the results. So here you will write your query. Usually they start with a select. I'll talk about this in a second. So you write your query, whatever it is, and you would see the results in here. And then in here, you would see the like a text related to the results, how many results you pulled. If there was any issues with the results, that text will be in here. This text, once you run that query, is very important because if you have any errors, typically would tell you what the error is. So don't be afraid of reading those errors and fixing your query if you need to. Then here we have a few buttons that are important. So this one allows you to create new tabs. So if you want to write several queries, this is the button that you would do that. You don't need to do that right away, but just so you know, it's there for you. In here, this one is to open a previously written query. That's not our case, so we're not going to be using that for now, but just so you know. This one is to save the queries that you're going to be writing. So if you're working from your computer, that's fine. If you're working from Codio, maybe I would just suggest copying and pasting the queries onto some other random document so you can use them later on. Because I think in Codio, it just resets everything. So you don't lose your work. And then here in this play button, that's gonna execute the query. So when we write it, we click on it, and that means execute the query that I just wrote. So that's what we're gonna be doing next. So, okay, once we are here, let's start writing that query. So queries in SQL always start with the word select. So you're always going to select something. And there's a few words that you're going to have to learn that are SQL words that allow you to give instructions to the database so you can extract the information that you need. So the very first word that we learned is select. And select means exactly that. It means to select something. So what are you going to select? Next, you give it the instruction of the columns that you want to select. So let's look at our ERD again. So this is our ERD here. Let me do this. Oh, okay. So this is our ERD. So imagine you wanted to see the individual table. How do you bring that individual table? So you're going to say select and then the columns that you want to select. So you have two options. You could write all the columns. So you could write something like ID, comma, name, comma, but that's too much work if you just want to see all the columns. So the trick to call all the columns is with star. So you would say select star. That means like select all the columns from and the name of the table. So in this case, the name of the table is individual. So select star from individual. And then it's usually good practice to finish our query with a semicolon. That just tells SQL, I'm done writing my query. So sometimes it works if you don't put it in there, but it's usually good practice to just put it in there. So a few things. Notice in here how the select and the from became blue. That's because those are SQL keywords. So these are words that SQL understands and that SQL is paying attention to execute your orders. So select selects, and then from is just from which table. So we're going to be writing this format many times. And then individual became a different color. It became like a light green. That's just to indicate it's a name of a table in our database. So we have written our first query. how do we run our first query? Well, we just click here on the play button. So we click on it and we see our table here. This is the result. And here we see the message about that query. So it says the execution finished without any errors. Result, uh, 1000 rows. It was returned in 163 microseconds. And this is the query that it ran. So it's just basically giving us a report. Right now, it doesn't really matter, but if you ever have an error, this is the message that you should be looking at. So you know how to fix your error in your query. So that's our very first SQL query. Yay! So you might be wondering, well, in Excel, you can just open the file and then you see all your data. In here is cumbersome, right? Because we have to open SQL, open the database, write this query to be able to just even see the data. Why are we doing this? Why are we putting ourselves through this? And it's because of the reasons I told you at the beginning of the lecture. So SQL is more robust when you need to make sure that your database is correct. It handles the data properly. Whenever you have too much data, this is way more efficient than Excel. But this is the question that you are going to have to answer as a data analyst. Given the data that I have, should I go for Excel or should I go for SQL? And that's something that you learn with experience once you start working. So we have written our first SQL query. Yay! So I'm just checking the chat, see if there's any questions. So I see a great question. Does it need to be uppercase? No, actually SQL is not sensitive to uppercase and lowercase unless it's something that is in quotes. But if it's not in quotes, you could write something terrible like this. Like if I was a millennial, you could write this and it would still work. So it doesn't need to be all caps. It's just people that have been working with SQL for many years typically write it in all caps, but it doesn't need to be in all caps. So that was a good question. No, it doesn't automatically auto-populate, so you have to click here on this arrow so you see the result. So we were saying, this one I just have open in my computer so you guys can see it, and you can see what was I doing, but technically this is what you should be seeing on your end. All right. So the issue with this query is that here we only have 1000 rows, which is not that much. But if you had 2 million rows, your computer will crash. And you don't want to be that guy that on their first day of work, their computer crashed. So how do you make it such that you can see a little bit of the data, but not all of the data? Because maybe you want to get a sense of what is that you're working with without loading everything at once. So how do we do that? So if you wanted to see only the first few rows, you will write the limit SQL word, so limit, and the number of rows you want to see. So for example, let's say 10. And I run this, and now I only have 10 rows here. So this will be my advice for all of you. Always put that limit clause. So a SQL clause is any of these reserved SQL words. Notice that they're all in blue. We'll learn our third one. So our third clause is the limit clause. Whenever you want to look at a data, at a table, please always put the limit clause so you don't accidentally end up loading 5 million rows and then your computer crashes. Right. So let's go with our second example. So imagine you're a detective, right? And maybe you have a suspect and you want to specifically look at someone. You want the information. You don't want everyone's information. You want the information of a specific person. So how do you do this in SQL? So the way to do this in SQL is with select star from individual. So that stays the same because it's give me all the columns from the individual table. But now you're going to say where name, because that's the column I'm interested in, equals, and then in quotes, I'm going to put the name I'm interested in, which in this case is going to be Finlay Mathisen. I'm probably mispronouncing that name, but here is the name. So a few things here to keep in mind. This is not case sensitive, but this is in quotes, and you're trying to match this value to a value here in the database. So whatever you put in here, it is case sensitive. It is space sensitive. So like if you have an extra space here, it's not gonna match your result. So you have to make sure you're typing exactly what you're searching for. So let me run this query. I run it in here and I get the result. Look, it tells me only one row matched that result, which is only one row belonged to the name Finlay Matheson. And then we can see his information in here. So this is the thing with SQL. At first, if you're only reading SQL, you could say it's easy. If I show you this query, even if I just like open my office right now and call the stranger in and I would ask them to read this, they will be able to probably figure out what it is. Like select from individuals that where the name is this. So it would be like, okay, I think it's gonna pull out the information of that individual. The part where you have to exercise your SQL skills is to remember what is the syntax because you can't put where first. You first have to write SQL select. You have to write from which table, where the name equals. So it's not like name is name equals. So that's the thing that we're going to be practicing throughout these few weeks that we have together in SQL. But reading is easy, so now we're going to practice the writing aspect of it. So the same way when you were learning English, as a kid, you learned that you shouldn't say, "I like my car red." That sounds weird. Maybe the message gets across, but it sounds weird. You should say, "I like my red car," because that's how you correctly say it in English. So it's the same thing with SQL. We're going to learn what are the correct ways of writing these queries in SQL. So yes, the name is case sensitive. So keep attention to that. So let me see. I see some errors in the chat. So I saw a good error in the chat. I'm happy that was shared. So if, for example, you select a single thing, for example, like here, I selected the word where and I run it, it gives me this error. So either you select the whole query and then that works, or you just not select anything and you just have your cursor somewhere and then that works. So if you're selecting a little piece like this, it's going to give you an error. So you have that syntax error. That's what it means. Let me see what other errors are people getting in the chat. We are getting no, it seems like we are fine for now. But yeah, if you get errors, feel free to share them in the chat so we can see where it went wrong. So for example, I see another screenshot in the chat that the error was because the query was like this. And notice that the error would say, the error is near Matheson. And so you start looking here. And for me, and this is because I've been working with SQL for many years, I can quickly say, oh, it's because you're missing the quote here. And why did I notice it? Because the color changed. Notice that this color is red, where this one that is a column name is in purple. So, so if this one, the minute it became purple, now you start recognizing those errors. So it's completely normal if at first you get some errors. We're gonna work through those. All right, so now it's time for you guys to do it on your own. I'm gonna give you the first exercise, give you let's say 5 minutes to solve it, and then we'll do it together. So, exercise number one is follow the model of the exercise that we just completed, but find out everything that you can about Julianne McClure. So, let me give you 5 minutes for this, and I'll be answering questions that I see in the chat.
5 minutes left. seconds left. Seconds left. 5, 4, 3, 2, 1. Time's up.
All right, so let's do it together now. So a few things that I've seen in the chat. Potentially, most of the errors of what I saw was having the two semicolons. So the semicolon indicates all my instructions for this query are done. So you shouldn't have more than one semicolon in the sentence. So it should only go at the very end. In fact, you don't even need to have it unless you had several queries, but it's just good practice to put it in there. So that was the most frequent error that I saw. The other one is maybe not opening and closing the quotes with the same quote. And I think that's it. I don't think I saw another error. So let me substitute this with the name of our new person of interest. So this is Julianne McClary. And we run it. You can run it with Control R. That will work, or you can run it by clicking here on the arrow. It's the same thing. So here we see the result with Julianne and his business as usual. A few more things. So I got the question about, does the select have to be all uppercase? No, it doesn't. Do you have to follow this format? Not really. You could also have the query like this, and it would still work. You could have the query like this, and it still works. So SQL doesn't care about enters, like new lines. It doesn't matter to SQL. Usually you just do it so it's more readable. But technically you could have a really long query in just one line and SQL would still know what to do with that query. This is just for you to be able to read it more easily. Um, yeah, and those are a few things here and there that I'll continue mentioning. So you learn what are the things that you can do in SQL and the things you can't do in SQL. The best way is just to practice. The more you practice and practice, you'll see what things you can do and what things you can't do. It's the same thing kind of when you're learning a language and people start correcting you and then you start speaking better. It's the same thing with SQL. So we are at a good stopping point for our break. During the break, if code is still not working for you, I think it's already working for most people, but if it's still not working for you, I would recommend downloading onto your computer. If you have a Windows, just pick the standard installer for 32 or 64 bits, depending on your computer. If you have a Mac, then you have this link in here and just follow the steps. It's kind of like installing any other computer program on your computer. It should be fine if Kodi is not working for you. Also, if Kodi is not working for you, please let us know so we can tell Kodio and make it better. So that's where we are. I say we should do a 5-minute break and come back after the break to continue with our murder mystery in Sequel City. So I'll give it back to Taima. All right, welcome back everyone to your crime show. So let me share that screen. And there you go. So you should be able to see my screen now. So in the meantime, while we're still coming back, tell me, do you like crime shows, TV crime shows? Do you have a favorite one? My favorite one is Criminal Minds. I love Criminal Minds. I see CSI, Reacher, Psych, FBI International. So fun fact that the first time I taught this class at Correlation 1, my manager almost kicked me out of the class because he thought I was actually responding a call in the middle of the class, and he was like, "Oh, how irresponsible of her." But I love teaching this class. It's so much fun. So I see those answers coming up in the chat. Brooklyn, Brooklyn 995, 901. I love that show as well. True Detective, Law and Order, all good shows. I love crime shows, and I love this case because it's a crime show. So let's get back to it. So far we haven't really worked in our crime case. We're getting familiar with SQL. So I actually wanted to show you something about the previous two queries that we had. So technically you could have two queries in the same page. And that's why you would use the semicolon. So for example, if I try to run this as normal, it's gonna show me the last result, so the result of the last query, but it doesn't create any problem because I have the semicolon. If I didn't have the semicolon to tell SQL that it's two different instructions, I delete the semicolon, then I'm gonna have an error. So that's the purpose of the semicolon, to say, hey, these are two different exercises. And here we're only seeing the last result because it's the last thing that gets displayed. But if you wanted to display this first query, you just have to select it and run it. And maybe if you wanted to write a comment about it, you can, in a separate line, write dash dash, so two dashes, and say something like exercise number 1, and this one would be other exercise, whatever it is. So anything that is preceded by dash dash is going to be a comment. That means that SQL is just going to ignore it. So you can just write whatever you want. So there you go. Let's work now with example number 3. So example number 3, now we're actually going to focus on the Excel, on, no, not on the Excel. I was thinking about Excel. We are going to focus on the crime. So we have this data set, this table called crime scene. So let's just take a look at crime scene at first. So how do we take a look at crime scene? So from the previous exercise, we know it's select star. The star means that I'm selecting all the columns. If I wanted to select a specific column, I could type the name, but since I want all of them, I just say select star from crime scene. And maybe let's do limit 10 so we don't break our computer. And let's run this query. So here we see the crimes, and exactly as our ERD showed us, we have date, we have the type of crime, we have the city, we have the country, and the description of the crime. So for example, if you wanted to know, okay, I want to see all the crimes that are, the type of the crime is robbery. How would you do that? Exactly the same way as we were doing it before. So you would say, okay, that's going to be where type equals robbery. And you run this, make sure that you only have one semicolon per query. Make sure that whatever you have in here is correctly typed. You don't have any mistakes. You don't have any trailing spaces because then it wouldn't work. It just needs to be exactly what is in here. So it matches the results. So we run this and we see all the crimes that are of the type robbery. So far, we're doing exactly the same thing that we were doing before. Before we were searching for individuals with the name Juliana and Finley. Now we're searching for in the crime table. So before we were looking in the individual table, now we're looking into the crime table for crimes that are of the type of robbery. But let's say you want to focus, okay, I want to focus on robberies. that happened in Chicago. So you want to filter by city as well. So how do you do that? You just add the word and then you can do as many things as you want. So in this case, I'm going to say and city, which is the name of the column. Notice that it matches. Same here, the name of the column, it matches here. So the city equals Chicago. Shout out to anyone in Chicago. So we're gonna run this, and we see there was only one robbery in Chicago. I don't believe it. It's Chicago after all. But in this database, there's only one robbery in Chicago. And then here we see the description. If you want to fully see the description, you can double click on it, and this window is gonna pop up. And then you can click on this symbol to just see everything. So this is the description of the crime. And that's it. So this is how you do it. And if, for example, you wanted, let's say there were many robberies in Chicago, you could say where type equals robbery and city equals Chicago and date equals and the specific date that you're searching into. So you can do as many ands as you want. So now that you know this, let's continue with our next exercise. So our next exercise is gonna get us closer to our crime that we have to solve. So you're gonna have to do very similarly what you have in here, but you know that the type of crime was a murder. And the city is SQL City. So make sure you type it this way. SQL City, exactly this way. So type is murder and city is SQL City. And let's see those results. So I'll give you 2 minutes for that and then we'll do it together.
2 minutes left. Left. Seconds left. Seconds left. 5, 4, 3, 2, 1. Time's up.
All right. So let's do it together. So we have select star from crime scene. So what is happening here? I'm selecting all the columns from the crime scene table. So that's why we see all the columns in here. Where type equals, so in this case it's not robbery, it's murder. So murder. And city equals SQL City. So I saw a few folks saying that you didn't get any results. Make sure that you typed SQL City correctly, because that's probably what it was. And also make sure that you typed murder correctly, but maybe it was just SQL City.
ChatGPT to answer that.
Oh, my iPad thought that that I said Siri, but I was saying city. Okay. Um, the iPad is a paid actor, but anyways. Okay, so we have this, and to run the query, so you can see the new results, you have to click here on the play button. So there you go. And here are the results that we have. So we have two results, like Hank asked in the chat, which one of the two should we care about? So that's the clue in here. So the clue in the case, it says that the original detective on the case remembers that the crime happened in Sequel City, that it was murdered, and that it happened on February 18, 2018. So the one that we care about is this one, the second one. So if you want to fully read what it says, you can click on it, double click on it, and then this window appears. I like to click on this button so I can just fully see the text and then what it says. So it says, a security camera in the neighborhood. Well, no, actually, this deserves some music. A security camera in the neighborhood captured two figures who might be witnesses. The first one lives at 513 Hamilton Drive, and the second one was identified by one of the police officers as a man named George, who lives on Independence Street. We have two witnesses, and we have to ask them what do they know about our crime. All right. So I'm gonna take notes of this because it seems like it's gonna be important. You don't have to do this. This is for us to be able to track here in the class. So basically we have, well, it happened on February 18. February 18, 2018. And the first witness, the clue that we have about the first witness is that they live on this location, 513 Hamilton Drive. And the clue about the second witness is that their name is George and they live on Independence Street. So let's look at our database for a second and let's think what we need to be able to figure this out. So the first witness lives on this address. So we need an address. So let's check our database. What do we have here? So it seems like we're going to have to use the individual table because here we have address. And we want to know what the individual has to say about this crime. So we're probably going to have to also work with interrogation at some point. But for now, let's just identify the witness. So for now, we are going to work with this table to identify the first witness. And same thing with the second witness because we have name and address. So we're going to be querying the individual table again to be able to figure out who are these two witnesses. So let me put this on the side. And let's continue with the next part. So the next part is the similarity conundrum. So as a detective, you might have noticed now that we have a big issue. Because so far, everything I've been telling you is that you need to type things exactly as it is. So for example, if I type something like SQL, if I didn't know it ended in SQL City, this doesn't bring any results back. And that's an issue because, for example, here we have the address, but I don't know if this is the full address. So how do we match for something that we don't have the full information? Same thing with George. We only have his first name. We don't have his full name. So if the clue was the name of the city started with sequel or with seek, this way of querying right here wouldn't work because we wouldn't be able to extract the information. So how do we do that? So in SQL, we do that through something that is called a wildcard. So a wildcard is basically a placeholder for something that you don't know. So there's two wildcards. One is the percentage sign, and the other one is the underscore, this underscore. So the difference is that this one can be a placeholder for something as many characters as you need. So for example, if you know that the name of the city starts with seek, so you would say, okay, um, you put the percentage symbol in here and we run it. Oh, that didn't work. Um, because to be able, so let me show you. So this didn't work when I put the percentage because it's not an equals. So in math, if you remember from math, equals means equals, that in the two sides of the equation, you have exactly the same thing. But the thing is that we don't know the full side of this equation, so you can't use equals, you have to use like, and then it would match. So in other words, let me redo this. In other words, these two queries are exactly producing the exact same results. SQL city. So these two queries are producing exactly the same result. The difference is that in here, you actually knew the name of the city, which is SQL city, but in here, you only had like a partial clue of what it was. So this percentage worked as a placeholder. So you know that it started with seek, SEQ, but that you had something and you weren't sure how long after. So this is what you weren't sure. And whenever you use this wildcard, you have to make sure that you're using the word like. If you don't use the word like, it's gonna break. Or not break, but it's just not gonna show you any results. It's not an equals, it's a like. So if you know exactly what is it that you're searching for, you use the equals. If you don't know, you use the like. And um, so for example, in here, in this example that is showing Canada, uh, here, let me maybe make it bigger so you can see it. So for example, here, this one, what does it match? It works like a placeholder. So if you were searching for something that has this pattern, it would match anything that starts with a CA and ends in A. So what could match in here? You could have Canada. You could have California. You could have Carolina, like North Carolina. So anything that starts with a CA and ends with an A. So it works as a placeholder of something that you're not very sure of. Can you start with the placeholder with the percentage? Percentage. Absolutely, yes. You can put the placeholder wherever you want. So for example, let's say you know that the I'm gonna make myself a suspect with this, but you know that the suspect name ends in Anna. So you would say something like this. So this would match Viviana, but it would also match Diana. It would match Liliana. It would match Adriana. It will match all the names that end in Anna. So you can put the placeholder wherever you want. You can put it at the beginning, you can put it at the end, you can put it in the middle, like here. So it just works like a placeholder and it matches to everything. The main thing to remember is that you have to use the word like. You can't use the equals. Would it match Anna as well? I'm not 100% sure, but I think so. It will match Anna as well. If the it's not case sensitive. So there you go. Yes, and you can put as many placeholders as possible. So for example, if you know that in the middle of the name you have uh Anne. So for example, something like this. So this would match, of course, Viviana, because you have the N here. But it would also match Ian. It would also match any other names. So you can put as many placeholders as you want. So excellent questions. And I like the approach that Mo taked. So you can experiment it yourself if you're in doubt. So for example, let's say if you put something like this. So here this would also match as well. So if you ever think of a question and you're like, I wonder if that will work, that's the best way to learn. Try it out yourself and see if that will work. All right, cool. And same thing with the underscore. The only thing is that the underscore is the space is the placeholder for only one character. So for example, this would match Bob and Bob, but not Babe or BB or something else. It only matches one character. This one is not used as common as this one. This one is more used, but just so you know. Exactly. So that's why we need to work with the matchings. So let's go with the next example. So example number 4, which is we have to get, this is just to practice the thing that we just learned, which is let's create a query that from the cities that we have here on this table, let's retrieve only the cities that start with the letter I or the letter underscore I. So in SQLite, it's case insensitive. It doesn't care about the case, so it will match all the instances. But something to keep in mind that if you're working with MySQL, it's case sensitive, so you will have to do something that is called I like. But for now, don't worry about it. Just so you know, if you ever have that issue, think about, oh yeah, maybe it's that it's case sensitive. But in this case, it's not case sensitive. Again, what are we doing? We want the list of all the cities that start with the letter I. So I'm gonna give you a hint, and so the hint is, if we wanted to get all these cities, we would say select. And so far we've been doing select star from crime scene. But if you want a list of just the cities, you don't need all the columns. Instead of typing star, you could type the city name. So you say like this. So select city from crime scene. And it just gives you the cities in here instead of giving you the whole table. So that's the new thing that we learned here. And now we want the cities that start with just the letter I. So where, city, and this is very important, it's like, it's not equals, because the two sides of the equation are not the same. So we need to use something that is like something else. So city, like, and then in quotes, very important, you need to put it in quotes. And I know that it starts with the letter I, and I'm just gonna use the placeholder. So this is gonna match all the cities that start with the letter I, which, let's see them. It's Iowa, and it's Indianapolis. My iPad was also reacting to city. The iPads are paid actors in this lesson. So this is how it worked. If you have any questions about placeholders, feel free to put them in the chat. But yeah, this is pretty much how it works. And the next exercise is going to be very similar. But in this case, now we want to modify this query and retrieve the names of the cities that start with the letter S instead of the letter I. So I'll give you 2 minutes to do that, and let me know if there's any questions.
2 minutes left. seconds left. 10 seconds left. 5, 4, 3, 2, 1. Time's up.
All right, let's do it together. Let me check the chat. I don't think I saw any errors in the chat, so I'm happy about that. So yeah, pretty much the same thing. You just replace here with the letter S. Potential places where there could have been an error is if you left the equals in here. So if you're using a placeholder, you have to use the word like. Potential other errors, maybe if you still have the semicolon in here, but I think we already learned that one. I don't know. I didn't see any errors in here, so that's great. Um, and I love what I'm seeing in the chat. So Manuel is already thinking like a data analyst, and he's saying, well, imagine a manager told us, hey, please tell me all these cities that we have in our database that start with the letter S. Would it make sense if you go back to your boss and you tell your boss, oh yeah, in our database we have Savannah, Shreveport, San Diego, Salt Lake City, San Diego, San Diego. It doesn't make sense because your manager will be like, why are you saying San Diego 2 times? I only need to know that San Diego is there. I don't need to see it 2 times. So how do you see all the unique values? So I'm going to teach you a new SQL clause, a new SQL keyword to be able to get only the unique values of a result. And it's super easy, just like we have it in here. But after select, you have to write the word distinct. So select distinct, and then everything is the same. And this is super cool because, as I was telling you earlier, these are English words. So even if I didn't explain, even if I was a terrible professor and I didn't explain what it was, you will be able to figure out what it was. Because it's select distinct city. So select distinct cities in the table crime scene that start with the letter S. So that's what we're going to do now. And I run this. And notice that San Diego now appears only 1 time. So again, without this distinct, we have 26 rows. With the distinct, we have 19 rows. So there are 19 unique values. If you still have San Diego twice, maybe you didn't click here on the play button. That should get rid of it after you write the word distinct. And yeah, there it is. I saw Shreveport. I've been to Shreveport. Shout out to anyone in Shreveport. Yes, exactly. So distinct removes duplicates. It shows the unique values in that query. So in this case, it shows the unique values, the unique cities in here without showing them multiple times. All right, so now that we have learned distinct and we learned also about our placeholders, here's a small free exercise. So basically, now feel free to try anything that you want with the placeholders. Maybe you can try it like this, or a different combination, whatever you guys want to try. So this is like a free exercise for you to play around with the placeholders. I'll give you 2 minutes and then I'll show you a few options. There's no wrong answers in here.
2 minutes left. 3, 2, 1. Time's up.
So let's do it together. It was a little bit of a free exercise. So for example, let's say I wanted to know if there are any crimes registered in West Palm Beach in Florida. But I don't know if West Palm Beach is going to be there. So I'm just going to write West. So I would say, okay, West followed by something. And I'll run it and let's see. No, West Palm Beach is not there, but you have West Hartford. So let's see, what do we have in the chat? What examples? For example, the one here that we suggested. What what does what is this? What does it match? So this one is you probably already know the first one. So percentage A would match to anything that ends in A. So let's just do it real quick for shows. So percentage A, and I run it, and it matches all the cities that end in A. So Tampa, Chattanooga, I don't know how to say that, Chattanooga, Philadelphia, Valdosta, Santa Rosa, Pensacola, etc. What about this one? So this one matches, let's take it step by step. So it matches anything that is followed by the letter A, and then is followed by one character, and then the letter A. So would Tampa match this? So the first requirement is that you have the letter A preceded by stuff. So yes, you actually have two letter A's that preceded by T and preceded by MP. But then you have to have two letter A's with a letter in between, which is not the case in here. If it was Tama or Tapa, it will work because it's only one letter. But given that it's two letters, it doesn't match. For Tampa to match this, you have to write something like percentage A, then it will match. But you have two letters in here, so it wouldn't match. So what matches? I can't think of a city that will match that pattern. So let's just write the query, A underscore A, and it's Omaha. So yes, Omaha makes perfect sense because you have two A's with a single letter in between. So that's the difference between the underscore and the percentage. The percentage is any number of characters. The underscore is the placeholder for one character. And then it's preceded by something. So Omaha is the match in this case. I can't think of any other city that will match that. Nothing in the database, at least. But yeah, you have Omaha. Yes, it's very similar to mid, right, left, and in Excel. So a few of the strategies that might have worked in Excel here could also work. You just have to translate it into SQL speak. But I like that those connections are being made. All right, cool. So let's go back to our case. So in our case, what do we have so far? So far, we have this statement, this report. This was the report of the crime. So what does the crime say? A security camera in the neighborhood captured two figures who might be witnesses. The first one lives at 513 Hamilton Drive, and we have extracted this information in here. The second one was tentatively identified by one of the police officers as a man named George living on Independence Street. So this is the second witness. So what do we have to use now to be able to get the information of the first witness? We can use the individual table and query based on address, get that information. So let's start with that first query. So for exercise number 6, Let me show it to you here so you have it as a reference. Write a query that identifies the first witness based on the clue. So give me all the information you have on the first witness. The clue that we have is that they live on 513 Hamilton Drive. So a few hints before I set the timer. You have to use the individual table, and then you have to use either equals or like with the address column. So I'll give you 2 minutes so you can try it on your own, and then we'll do it together.
2 minutes left. Left. Seconds left. Left. 5, 4, 3, 2, 1. Time's up.
Awesome. So if you're still working on your query, feel free to keep working on it. I see the answers coming in the chat. So for the first witness, you actually have two options. So you have to say, okay, select all the columns because you want to know everything about the witness. You want to know the name, driver ID, address, social security number, income, give me absolutely everything. So select star because I want all the columns from individual, where, and then here's where you have the two options. So you want to use the address column. So where address either equals exactly the address that we were given. So we could try this and see if we have luck. So 513 Hamilton Drive. So let's try this. And this worked. We got our suspect, but imagine you only had, instead of 513 Hamilton Drive, you only had Hamilton Drive. You would have to use a placeholder. Like if you didn't have the full address, you could say like placeholder Hamilton Drive. Both of these will give you the same result. So if you did it one way or the other way, it's completely fine. You're good to go. So let me copy this information because this is the information of our first witness. They're not suspects, they're witnesses. Don't treat them badly because we want information from them. So the first suspect is Fidel Mantello, whatever his last name is, and this is his address, his social security number, and the guy makes 70K a year. So let's go with the second one. The next exercise is exactly the same thing. but with the second witness. So here is the information about the second witness in case you didn't have it. His name is George, and his address is on Independence Street. So I'll give you 2 minutes for that one as well, and then we'll do it together.
2 minutes left. Left. Seconds left. Left. 5, 4, 3, 2, 1. Time's up.
All right. So if you're still working on your query, feel free to keep working on your query. So let's answer this question together. For the second witness, we have two pieces of information that we might need. We have his name and we have his street number, the street name actually. So a few things, and I think this is where maybe people got tricked, is that George is not the full name, but if we take a quick peek at the individual table, so let's do select star from individual limit 10, we see that the name column includes the full name. So if you do name equals George, it's not going to give you any results. So that was part of the trick there. So how do we do it? So the first thing is the name. So where name, and we have to use like because we don't know his last name. So like, and in quotes, George, and then the placeholder for his last name. So with this, we can get all the Georges, but I mean, it's only two Georges, so you can say, okay, is this guy, because this is the one that lives on the Independence Street. But if you wanted to do it through the query, this is how you do it. You would say, and address. And we have the same issue with the address, that we don't have the full address. So you have to say address like, not equals, like, and then quotes. And we have Independence Street, and then you can add the placeholder. Me being super anxious that I'm gonna miss something, I would add the placeholders like this. I would just use Independence, and then placeholder here for the number, and placeholder here for the second part of the street name, because it could be like street, the full word spelled out, or ST, or ST in all capitals. I don't know how would they spell the last part of the street. So I would just put another placeholder. But if you just did street like this and you got the result, Whatever worked for you, if it worked and you got the result, that's fine. Just because I'm showing you one way doesn't mean that is the only way. So there you go. So now we have our second suspect, which is George Lug. So let's copy this information, and we have the information of our second suspect. So now we have another challenge. The other challenge is that now we know our suspects, but we want to know what our suspects said. We want to know if we want to be able to use these two tables to be able to get what our suspects said during, no, they're not suspects, our witnesses said during interrogation time. So the way you do that is through a join. So we're going to be practicing joins next time, but basically, let me show you an example here. It's going to have to be a little bit fast because we're running out of time, but we'll do it again next time. So basically, I'm going to give you first an example. Let's say you wanted to extract name and age from these two tables. How does it work? You would say select, and you say, okay, I want the columns name, comma, age. But given that you have two tables now, you have to indicate from which table is that column coming from. So the name column is coming from the individual table. It will be individual dot name. And then for age, it comes from the drivers table. So it will be drivers dot age. From, and then from which table? In this case, since we're matching rows that exist in both tables, it doesn't matter which one you call first. You could call drivers or you could call individual. So let's just say drivers. Join. So this means, okay, let's mix these two tables together. Join individual. On, and you have to indicate how these two columns are connected to each other. So these two columns are not columns, tables. These two tables are connected to each other from the ID in the driver's table to the driver ID, which is the foreign key in the individual table. So that's what you would say here. So on individual driver ID equals drivers. So the drivers table dot ID. And let's say limit 10 so we don't get all the information. So I know this was a lot. We'll cover it again on Thursday. But basically here you have the syntax to join two tables. So that was a first introduction. I'll say it again on Thursday with a little bit more of time. But basically, you want to specify the columns that you're going to use. You have to say from which table they're coming from, what two tables you're using, and how are these two tables connected. So you can use the same recipe to extract the individual name and the individual description, the interrogation description. So that's going to give us the result. So let's do it together. Let me copy and paste this query in the chat because I know that was a little bit fast. So I'll put it in the chat. And now let's do the next thing. So we need to use the individual table to get the name and the interrogation table to get the description. So let's do that together. So individual, that name, that's going to give me the first column. But now I don't need the age. The age was the previous example. I need the description, but this description comes from the interrogation table. So interrogation, that description. And then the syntax is the same. So from individual, join on the other table, which in this case is in the interrogation table. On, how are these two tables connected? They're connected on individual ID equals to individual the interrogation that individual ID column. And we want where individual ID equals. We already know that the individual ID of Fidel is 201, or the individual ID equals 328, which is the ID of George. So 328. And let's run this query. And let's see what they had to say for themselves. So George Lug said, in his statement to the police, he said, "And for the rest of the way home, I recited to them the various exploits and triumphs of Hercule Poirot." So that doesn't really make sense. Let's see what Fidel had to say. Fidel said, "I heard a scream and then saw someone running away. I thought it was just a robbery. After all, we're in Sequel City. But then I saw the pool of blood and freaked out. The guy that escaped accidentally left a card from the Muscle Hustle gym. The ID number was damaged, but it starts with the number 33. A minute later, I heard the tire screeches and saw a car pass real fast. And the plate had ZDI or something like that. So it seems like we almost have our suspect. If we query the beam table, we might get the result of who's the suspect. But is that really the murderer? Stay tuned for part 2, Sequel City part 2, coming this Thursday. You have to be here so we can figure out who committed this crime. Thank you so much, everyone, for being here today. It was a blast. My recommendation from here to Thursday: practice with SQL, practice getting familiarized with this interface, user interface, practice all the queries that we did today, and we're going to pick it up there on Thursday to figure out who truly committed this crime. So thank you so much, everyone. I'll give it back now to Taima.